Welcome everyone to this morning's information session entitled Resilient Futures Addressing Climate Risks. In this session, we aim to show how location intelligence can be used to tackle climate-related challenges. Presenters will share innovative approaches and real-world examples of how spatial solutions are making a difference today. So why should we be concerned about the links between climate change and location intelligence? Where is the cost benefit to business? What is the risk reward to consumers? We can illustrate using the current discussion around residential home insurance affordability in Australia. Climate change is increasing the occurrence rate of natural perils, for example, bushfires, flooding, and others in Australia. The cost of residential home insurance is increasing because of the increasing occurrence rate of natural perils. Linking residential home and natural peril location data allows us to determine the financial risk of insuring a building at a location. Is a residential home located adjacent to bushland that has increased risk of bushfire due to climate change, for example, an increased fuel load or longer dry periods? These are the types of questions that location intelligence, when combined with climate change data, can help us to answer. And we have two examples here of recent disasters that have been exacerbated by climate change. For example, the bushfires in the Blue Mountains and flooding on the Hawkesbury River in 2021. In this morning's presentation, you'll hear from four presenters: Kate Cotter, CEO of the Resilient Building Council; Jeff Emmerton, CTO of the Resilient Building Council; Michael Dixon, CDO of Geoscape; and myself, Stuart Barclay, a geospatial solutions engineer at Geoscape. Climate change is now an established reality. The scientific community accepts that increases in greenhouse gases attributable to human activity have been the dominant cause of observed global warming since the mid-19th century. Temperature is the main driver of climate, so global warming causes observable climate change around the globe. As Australians, we all experience the reality of climate change each day. Data from the State of the Climate Report, released in late October 2024 by the CSIRO and the Bureau of Meteorology, shows that Australia's climate has warmed by 1.51 degrees Celsius since national records began in 1910. This has led to an increase in the frequency of extreme heat events, such as heat waves. Australia's warmest year on record was in 2019, and 8 of the 9 warmest years on record have occurred since 2013. There has been an increase in extreme fire weather, and the length of the fire season across large parts of Australia since the 1950s. This has led to larger and more frequent fires, especially in southern Australia. I'd now like to introduce Kate Cotter, CEO of the Resilient Building Council. Now I'm just going to switch to Kate and let her share her slides.
Thanks for having us. I thought I'll just give you a bit of an introduction into who the Resilient Building Council are and what we do. And Jeff, our CTO, will then have a talk about how we use Geoscape information for our programs. So we're a national not-for-profit organisation. We're independent, so a collaboration of experts. We have a particular focus on measuring the performance of buildings to risks. We came about after the 2009 bushfires, where community were really asking for technical support to help rebuild, and there was, I guess, a real opportunity there and a demand for finding ways to improve the resilience of buildings because people really didn't want to go through the trauma that they had gone through. And so that was sort of our genesis, which was bringing those experts together and really harmonising technical information and support so that people could easily understand what to do with their buildings in particular locations, how to respond best to those risks. And what has evolved over the last 10 years is translating all of that expertise into a rating system. And the rating system was designed in response to those community needs for some clarity and clearly articulated ways to measure the performance of their buildings and make decisions. So we've got a lot of sort of collaborative that goes into our programs. So we have technical collaboration and then collaboration across government, science and industry, community and NGOs. Why do we need resilient buildings? Buildings have so much systemic flow through them. So we primarily start with looking at how we improve the safety and health of people. So that's our driving force behind this organisation. But resilient buildings mean more than just safety and health. We want secure housing and jobs, affordable insurance and finance, and that's a particular focus of ours that I'll talk about in a minute. We want to be able to keep our services and infrastructure resilient so that we can keep providing services to people before, during and after disasters. And we also are trying to stabilise our financial systems so that we can attract investment, create value and really boost the sustainability of our communities and our economies. So when we think about that systemic financial risk, we've got from the Actuaries Institute report released in August this year that looked at home insurance affordability and the impact also on mortgages, that now 15% of Australian households face extreme home insurance affordability stress. So that measure is against their household gross income. So that 15% of Australian households are likely to be uninsured or at least underinsured. And if we can compare that to how fragile the property market can be, it was only 8% of the US mortgage market that led to the global financial crisis. So we have a sort of systemic financial risk here, and that is part of why we're trying to create systemic solutions to really reduce underlying risk for the benefit not just of those communities facing those risks, but our economy and our ability to have stable financial institutions. So looking back again to individual buildings, we've got lots of opportunities across the life cycle of buildings to embed greater resilience. So we look at each of these moments in the building life cycle to think about how we can influence, communicate and adapt what we're doing, and also introduce incentives and reasons why you might try and make more resilient decisions when we're designing, building, retrofitting and repairing buildings. The program that is central to our work are the resilient ratings, and the way that they work is that we assess, measure, verify and then try and scale that risk reduction. And the reason we have these steps is because this is the market mechanism we need for integration with insurance pricing and also the cost of capital, but also the mechanism that we need to help individual households actually know what to do, get the work done, get that verified so that they can access incentives. So we assess by measuring the building performance to local risks, and we can assess in a couple of ways. One is through self-assessment, and I'll show you the app that's out in the market at the moment for that, and also on-site or remote expert assessment. So a resilience rating is measuring the residual risk, so measuring that building performance against local risks, and we cover bushfire, flood, storm, cyclone and heat wave, as well as being able to do energy assessments at the same time. So measuring that is really important because we're looking for those vulnerabilities. So we've got a building specific component level probabilistic model for each of those hazards, and that produces then implementable resilience actions. So looking for the vulnerabilities, addressing those, and then being able to improve the resilience rating of a building. Verification is really important. That's what enables the insurance and finance industries to be able to recognise and reward that risk reduction. And the last part, getting insurers and banks and others to invest in their systems to integrate with the resilience ratings, we need scale so that they can justify those investments. So the free self-assessment app is really important. We are able to get people through that, remote certify, check their inputs, That really empowers people. So we can get lots of risk reduction from people using a free app to get started on that journey. And the idea for scale there is that we integrate into business as usual. So in terms of insurance, real estate, finance, regulation, lots of mechanisms there that we can start building in resilience into the way we do things. So in terms of the scale, up at the high end of the scale is best practice. So that's, the highest we can get a building in terms of its performance to local risk. In the middle of the scale is roughly where minimum standards would sit, and the low end of the scale is where a lot of our majority legacy homes and buildings sit. So we're trying to move our legacy building stock up, 1 or 2 stars there, somewhere up into the middle of the scale. And for new builds, where we've got a much lower incremental cost of improving resilience, it's much more expensive to retrofit a home than build in some extra resilience when we're designing new buildings. It's quite easy to get new buildings up to that higher level in the ratings scale. So in the low end of the scale, we're expecting high loss and damage. At the high end of the scale, if you're getting 4 or 5 stars, our models are saying that there's a very low likelihood of damage. So in terms of resilience, it adds some extra components. So minimum standards generally address the structural performance of the building for the passage of a disaster event. Resilience is more about not just having that building withstand that event momentarily, but also to minimise the damage. So we measure that sort of reoccupation rate, and that's the key part of what resilience means. So one of the ways to use the program, a year ago we launched the free Bushfire Resilience Rating Home Self-Assessment app. In March of this year, that was integrated into insurance pricing. So we've got 2 of the major insurers that have come on board so far, IAG and Suncorp. So people can use this self-assessment, answer questions. We take them around their home and their surroundings. They answer questions. The questions were designed that the majority of homeowners could answer those. So lots of pictures, and we can't get as much granular detail as we might with an expert assessor. So someone might be able to tell us if something is made of timber or metal, but perhaps not what type of metal or what type of timber, for example. So it's a more conservative output, so you're likely to get a bit of a lower rating than you would if you had an expert come and we could get some deeper detail about the building. So people fill that in, they get an estimate of what their resilience rating is today, and they're also provided with a free recommendations report, which comes to them in a PDF on email. They get a set of customised recommendations and an indication of what that improved resilience rating would be if they undertook those actions. So we support households through that process. We've got retrofit guides, all freely available. People can provide us with the photos and documents to have their ratings certified. We then issue that certification, which then can be provided to their insurers and banks. So we've got those insurers under those brands on board at the moment. We're working with the rest of the industry. NAB are also piloting a whole of mortgage discount. So that's why certification matters. That's what triggers those incentives. So the process that we've gone through, and it has been a long process over many years, we started by building the evidence base and methodology and engaging at that very early stage with insurers and banks. We then built an on-site assessment tool so we could go and do real assessments, take those case studies and data to the insurers and banks. They do their own validation and underwriting review. And then there's a pricing integration, so how the ratings can be reflected in pricing. And then policies are then repriced, and that's essentially what the insurance and mortgage discounts are, is a repricing of that risk. So at the moment, it's very difficult, even if you started with a new house that's very resilient, it's difficult to get that resilience recognised. So that's why this repricing is really important, to get that recognition. So in terms of a household journey, they complete that self-assessment, get their report, they can take actions, we can then verify those actions, issue the certification, and we're seeing up to 20% discounts on the total overall premium. But the way that the insurance pricing integration works is in a tiered way, depending on the rating that you have achieved. So for 3 stars, 4 stars and 5 stars, there's an increasing discount on the risk component of that premium. So bushfire being one of the lower components of risk in terms of the premium pricing, we will expect, higher discounts for flood and storm. So the market signal is correct, where the higher the risk component of your premium, the bigger the discount. So that's really motivating people in high risk areas to take some action and get those discounts. So one of the examples here is in the Blue Mountains with a $4,000 annual premium, about $820 discount. So, that's starting to be, meaningful. So when we add that into mortgage discounts, we're looking at savings that are more than the energy savings we get from solar panels, for example. So there is some real benefit that can happen that doesn't rely on value being created from avoided loss and damage. This is annual savings, and it's an important part of creating value for households, but also creating value for industry. So we can see some of Jeff's mapping, what the before and after starts looking like in an aggregated sense. So while we're looking at how we adapt individual buildings, we also look at what that means across neighbourhood streets and communities. That also helps to inform investment decisions, where we need to target government investment, what housing typologies are requiring, what types of recommendations. It helps us prepare in terms of resources and supply chains. So lots of ways to use this data for good and to get really efficient and effective with both our public and private investment. The other project we've got in terms of the ratings is a multi-hazard resilience ratings expert assessor tool. So this is for on-site assessments. So at the moment we're doing a whole lot of assessments around the country to do that insurance pricing integration work. So this is a piece of web-based software, again, asking lots of questions. On-site assessors can provide us with a lot more detail, so it's a more refined rating. It includes, this was a project co-funded by the New South Wales and Commonwealth governments. So assessor training and accreditation and data and insights to help inform some of those state-based mitigation plans. So this is just a snapshot of what a report looks like. So we explain how we calculate those ratings, what their ratings are today, recommendations for how to improve those ratings that are based on that assessment. So they're very specific. And again, we have to have those specific recommendations rather than general recommendations for everybody, because every building and every different risk is different. So we've got to find those vulnerabilities. We'll be able to get sophisticated with that over time, being able to serve up recommendations in different ways to people. Some people might want to know by area of home. They might want to know the ones that have got the most cross benefit for other hazards or energy efficiency. Some people might want to know, give me, my recommendations in order of impact on my ratings or by cost. So there's lots of clever things we'll be able to do over time to package up how we adapt those buildings and communicate that. So this is just some images of assessor training that we've been doing. The idea is to really empower local communities before, during and after disasters with these new skills, and again to embed that into business as usual. So training up energy assessors, builders, anybody that is having any interaction with households that can offer a resilience rating assessment as an extra. So what's next? We are at that stage of being able to integrate those multi-hazard ratings into insurance and finance pricing, following that same procedure we've done with bushfire, working with states and territories to boost adoption, support the building industry, training, accreditation. We've got some projects with the Commonwealth to develop multi-hazard best practice guides for new and existing homes, and helping to support the National Construction Code resilience objectives. And then the next most obvious thing for us to do, which was recommended by the flood inquiry report a couple of weeks ago, is to extend that self-assessment app to multi-hazard. And then we'll look at other building types. There's the same insurance affordability issues for small business and strata, community buildings. So plenty of work to do, but at the moment we're starting with multi-hazard on houses and trying to get insurance accessible, affordable, and the same with finance. That's it from me. I'll just stop sharing and hand back to Stuart.
So this is Jeff Emmerton from the Resilient Buildings Council now, and he's going to present some slides to discuss some other work or some additional work from the Resilient Buildings Council.
G'day everyone, just on the way in, there's a question around whether we're able to repeat the name of the app for the residential use for the public, so that people may be able to self-help and self-serve. So Kate or Jeff, if you had that name on hand, that would be great to repeat. Thanks.
Yeah, so it's called the Bushfire Resilience Rating Home Self-Assessment app, and you can find that at resilience-rating.org.
And we will also post a link to that at the end of the event.
All right, so Kate has just given us what we are doing, or what we're attempting to do regarding the rating system. I thought I'd take you into how we're doing it, the links back to SMA and Geoscape. My background's in surveying and GIS and mapping, so it became apparent early on with Kate that anything we built was going to have very much a geographic location and a base required for anything we did. That's something that was a passion of mine. I've been involved in standardising addresses for a very long time, and was very pleased when GNAF product was made available. I think most organisations will have adopted that in some way, shape or form, their address management systems. But I'm going to just talk about how we've taken that and maybe adapted a little bit further, particularly the geographic location, as it's so critical to us regarding risk at a particular site. Kate's talked about the home itself. We're looking at the structure of the home, the materials of the home, how it might succumb to various hazard impacts. The other part to that puzzle is, well, what's the location? Is it likely to be subject to high winds, flood, ember attack, radiant heat attack from a bushfire? So, yeah, we've seen a little brief overview of the app. We're going to send a link so anyone listening can go away and actually have a go at it themselves. That's bushfire only at the moment, and that will be expanded to also be a home self-assessment for multi-hazard. Slide. Just confirm you've got a slide now with a dark green background. I'm sorry, I'm trusting my machine showing you the correct slide, but it's thumbs up. So the first part of doing the assessment, I guess, is to get the location. We obviously have an address-based model. We want to know the location for both self-assessments and professional assessments. There's effectively a pre-process that looks at that location just to get some insights on what we're expecting. There's the opportunity for us to measure and query things such as distance to known features, whether that be a bushfire-prone area mapping. In some cases, it'll be to tidal and coastal lands that affect storm tide, and those sorts of things. And we're also, and I'll go into more detail, we're looking at...
Sorry, Jeff.
Yes.
Jeff, if I could just interrupt you a little bit. Could you turn up your volume a little bit, or move closer to your mic.
My mic is a bit quiet, is it? Sorry about that.
Yeah, it is. Sorry. Yeah.
I'll try speaking a little bit louder. Yeah, so we like to try and verify some of the core data that we're receiving, particularly for the self-assessment. Obviously, homeowners have varying skill levels in understanding details about their home. So again, I'll talk about how we're leveraging some of the Geoscape data to enhance that. And then obviously those maps, Kate's already shown you how we aggregate and prepare overviews or reports that show us just what's happening in the underlying data sets. So talk very specifically now about what we've done. So we're using one of the features that Geoscape offer is a predictive address matching tool. It allows you to enter a certain number of characters towards the address before it hunts and finds suitable matches. Very technical, I know, but we use a 6-character limit before we start hunting in that database. So someone, as you can see in those little screenshots, starts to type. It's not until they hit the 6th character, whether that's a combination of numbers and the start of the address or whatever it might be. But we then query Geoscape to pull back a list of matching candidates or best matched candidates that might be the address the person is looking for. The more letters they type, the shorter the list is and the more accurate that address match will be. And then we allow them to select the address that best matches. I guess when we started with this, there's obviously, we're putting a lot of faith in the address set being accurate, complete and ubiquitous nationally. We've found that there's been a very high match rate. We have very few users come to us saying they can't find their address. Often it's a minor misunderstanding maybe of their address. People have a little bit of a vanity view sometimes of what suburb they might belong to and disagree with what might have been stored in the data set. The beauty for us is if we're relying on this, we know that many other service providers and utilities are also relying on the same data set. So we're certainly not alone in presenting a particular address spelt a certain way and with a certain suburb and postcode combination. And they accept that. As I said, very, very low mismatch rates on the addresses that we're getting. Obviously, once we've got that predictive text sorted and someone's selected the address of choice, that allows us to then move to the next set of services, which of course is converting that address to a GNAP ID. The ID is of course important to us to sort of track that record and know that's the particular location that we are talking about. It also comes with the coordinate pairs, which are significantly important for us in terms of then assessing the risk at that location. So distance to bush, whether or not it's in a flood zone, wind region and those sorts of things. We're also looking at Geoscape's other product, which is a buildings data set, which allows us to then get back information about buildings on that parcel of land. So once the address match occurs, the GNAP does a look up to the buildings database, pulls back the relevant candidates of buildings. There may be none, there may be one, or there may be many buildings on that site. The little example I've shown there is a site with looks like about 6 or 7 buildings on the site. One of the inputs to our model, the model, as Kate said, is probability based. So things such as a larger roof area will lead to a higher probability of loss simply because there's more area for an attack to occur on. So the roof area is one feature that's very important to us that we take, but other attributes that are in there that we can use for cross-matching is things like the material of the roof, the complexity of the roof. Higher complexity roofs often have more vulnerability to fire and storm. So yeah, there's a whole stack of additional data attributes that we're pulling back from the Geoscape data sets. There's a little picture there where we're doing some pre-analysis of also the bushfire risk at the location. Gives us some insights onto the type of recommendations to make or whether that home actually it should be considered at risk from bushfire. There are obviously quite a few metro areas, particularly where bushfires are very low risk and the home isn't actually rated because it's not considered to be significantly impacted by, for instance, a bushfire risk. Next steps, I guess, look, there's a whole stack of things that we're looking at in terms of how we could enhance what we're doing. We've got ideas that, and particularly with AI, we hope that AI isn't all evil and there are some good things to come from it, but there's certainly the opportunities for us to take imagery, whether that's uploaded from a user, flown with drones, particularly with our expert assessors. We're using drones to pick up both detail from images of photos of the roof, but also to create a 3D digital terrain model and give us a better estimate of the shape and form of the building so that it's more accurately assessed. We've got obviously the ability to create then topologies as we get more data sets. We're looking at, categorizing homes into categories. But of course, categorizing homes into categories. And that helps us, I guess, in the reporting that the government's interested in about, well, where are the vulnerable areas? What can be done maybe as a more national effort or a regional effort to improve the resilience of those homes in certain locations? You can imagine that they could drive programs where people are all given some incentives to go and get gutter guard or to ember screen under their houses if they've got a particular style of home where they're elevated and have access under the house. Yeah, and as I said, there's probably more data sets coming out of Geoscape that we're interested in looking at, including roof levels and floor levels, which obviously very important for flood assessments as well. So that's about it, really. The technology has been very important to us. We're heavily reliant on it at the moment as both a high-quality national data set for addresses and location, but also there's extra attributes about the buildings where we can have them. There are sometimes, we talked about misses in the addresses, very, very low chance of that. There are some misses when it comes to building footprints and areas. Often new builds are missed because the time that the last series of photos was taken was prior to the home being built. There's a few that are obscured by trees and a few other things, but generally my feedback is that the data sets are very high quality, usually match what the home owner is telling us about their home, which is great. If there's too many differences, then I guess we can pull out and question a homeowner or use another data source to try and validate if that data is indeed correct. Last point, Kate mentioned about us, this system allowing and giving some confidence to insurers, et cetera, to give discounts. What I did hear an actuary say after a joint presentation with us recently is it's not actually a discount, it's actually a reflection of the true risk and an adjustment of the policy because of that change in risk, rather than thinking about, it's not just a 5% discount because we want to keep your business. It's actually, we are showing we're improving the resilience of the home, and therefore they do deserve some change in the pricing to match that. So thank you, guys. I'll look forward to some questions later on, but I'll hand back now.
Thanks very much, Kate and Jeff, and it's really good to see Geoscape data being used in this kind of application. We look forward to continued collaboration with you. Okay, so I'll share my screen again. If I can get the technology to work. Michael Dixon, Chief Data Officer of Geoscape, for his presentation. Michael.
Thanks, Stu, and thanks to Jeff and Kate there. There were really good examples going into great depth, which really goes through the entire cycle that I think I'm going to speak to now. So I'm looking to zoom out a little bit to be a little bit more general and give some guidance on perhaps the what and the how of how location intelligence can help with the overall climate scenarios that we find ourselves in today. So we started with a bit of an understanding of the fact that I think the science around the changing climate is no longer in question, and a bit of the why of the location intelligence is important. Fundamentally, the ability for us to act and make decisions, to be able to measure, to be able to monitor, to hold individuals, to businesses, governments to account, it relies on important information, and location intelligence can help bring that information to life, and that's why it's such a vital ingredient to help tackle these important problems. I know inherently that people appreciate that the changing climate's going to impact different locations in different ways. The changing temperature in Darwin won't be the same as how it changes in Hobart, but zooming right in, and as per the examples that we've seen now, the industry capabilities are so sophisticated that we're able to work at very granular levels. So modelling impacts of flood events of neighbouring properties can be different. We can get different results, and we can be leveraging data around the intelligence of a building to be able to support that decision making. And thinking about this even further, that bushfire attack levels and ratings associated with risks can be different from one side to the street to the other. So we're at a very granular level of information capability. And we'll have Stu go through some examples on that in a moment. But I think some of the key ingredients to unlock and leverage sort of location intelligence are sort of wrapped up into three general steps. It's important to sort of recognise that there's an environment that is thriving globally now when it comes to information and resources and capabilities when it comes to measuring the Earth. Earth observation is a very sophisticated business globally, but it needs the localised context to be able to make it relevant for answering the important decisions. It's not just about people or not just about place. It's about people and all the permutations that are going to drive different decision making when it comes to how to act in our climate futures. So for my part, I want to, as I've said, get a little bit more into the what and the how. And so when we think about location intelligence, just gaining insights from location-related information just on places, that's really location intelligence. We don't have to be any deeper than that. It's about using the power of space and location to be able to help with decision-making. Sort of the how, this can be really quite challenging for businesses to be able to step into this space, but we wrap it up into what I think are three reasonably simple tasks when it comes to using the power of location intelligence. The first step is simply to locate. I'll talk about this in more detail in a moment. Then we think about integrating, and then we think about the ability to get about the insights that you're looking for to drive decision making within your business. So, Stu, if you jump to the next slide, we can go into what it means to locate. And when I say locate, there's probably an opportunity to validate here as well, but sort of getting started is really straightforward. So just adding a bit of location context is simply putting features on a map. It's the critical first step to being able to use location intelligence. So it doesn't necessarily mean that you need to go out with a handheld GPS device and capture coordinates. So much location-related information is already in use inside governments and businesses today. The power is linking that information into authoritative sources to be able to build the connection and unlock the intelligence that comes from location information. So organisations hold addresses, they hold identifiers when it comes to land parcels, land titles, buildings, asset IDs. They're all forms of location information, but they're probably not spatially enabled in the language that we'd use today. So it doesn't necessarily mean that you need to make significant change to your business. However, the intelligence arrives when you're able to start to embed coordinates, as we've seen Jeff talk to already, when it comes to the information that your business holds. If you don't hold information of that form, it doesn't necessarily mean you're excluded from being able to participate, but the barrier to entry is a little bit higher. We might need to start to build out new information linkages or go and capture new information to help with the location intelligence sort of element here. But it's possible to still get started. The other benefit that I think we need to talk about is putting data on a map is the ability to validate. There are national registers that are very high quality today when it comes to addresses, and when it comes to land parcels, when it comes to land titles, etc. These registers are national, and you're able to validate information so that you can, I guess, discern whether your data holdings are relevant, fit for purpose, and at the right level of quality to be able to support decision making inside your business down the track. The ultimate answer here is, do you really know that your portfolio is fit for purpose? Moving on, Stu, from locate and validate to integrate. And this is where the power really starts to occur. And I've got three further steps sort of embedded underneath this. This is about linking, enriching and extending. So if we think back again to the Resilient Buildings Council example, we started with just an address, and from that address, we're able to enrich the or link out to other data pieces, which reflected the characteristics of a building. Just about the object that's important to you. That linking is an important enabler. So much information is exchanged today off the back of just understanding, say, an address, or understanding more details associated with a land parcel. And the linking can happen just through what I would say is attributes, a common key. That key might be an address, but equally some linking can apply from a spatial context. And this is where things become much more powerful. So understanding if your address is inside or outside a particular zone, understanding the proximity of your zone to, or your item of interest to, the nearest tree or bush area, understanding service delivery areas with respect to customers, your suppliers. There's a whole range of information that's possible by simply using location to start to link out to so many other pieces. So enriching is really this piece where we bring more intelligence relevant to your business, associated with the items or the features that are of interest to you. Ultimately, the ability to build and I guess data elements that are relevant for your business is an important final step when it comes to the integration. It's about embedding into workflows, into pipelines, processes for your business. And this is about being able to use the base information to calculate things that are relevant to the context of your business. And that might be an emissions metric. It might be a bushfire attack rating. It might be an understanding of biomass. It might be an understanding of stocking density. It might be an understanding of distance away from a particular supplier, and be balancing that against average distances across the entire portfolio. So this integration piece is really where you're preparing all of the data for further consumption and utilisation in your business. Flipping over to insights, Stu, we started to get into where the real value comes in for particular organisations. And when we think about this, it's really in the context of your organisation. And you often see this in the forms of reports or dashboards or events or notifications. But it's starting to answer these key questions around, where should I act first or next? Is this site more critical than others in my portfolio? How much capacity might I need to service this particular area? Is the site compliant with regulations that I need to be certified against? Is there an opportunity for me to be able to deliver a new product or a new service into this particular region? These insights are obviously important ingredients into your organisation's decision making. They won't make the decisions for you, but they are an important ingredient. If they're not fueling your decision making, perhaps they're not the right insights for your business. But nonetheless, this information can help optimise, streamline and prioritise day-to-day business activities. So often these insights are in the form of dashboards, reports or simple visualisations. and you don't necessarily need new tools to be able to leverage them. We can, I guess the industry's sophisticated enough now to be able to embed data flows into pipelines which can fit into your existing tools and systems. You don't need necessarily to go out and buy complicated, sophisticated mapping tools to be able to leverage location intelligence in any decision-making activity. And importantly, I guess the power of the map doesn't necessarily mean that you have to have one in front of you. We've got examples here. It's visual today because of the medium that we're talking to everyone in. But the idea that you can leverage location intelligence just in sophisticated work streams is certainly part of the capability that we can be offering today. So I want to throw now back to Dr. Stew to talk a little bit more about some specific examples, but I hope that gives a flavour of the fact that location intelligence isn't difficult to get started with, and it can be embedded into your business in lots of different ways.
Thank you very much, Michael. Now it's my turn to discuss, as Michael said, how you can apply location data to scenarios involving climate change. So the first example, building emissions. So from the beginning of 2025, companies in Australia are required to disclose their climate-related risks and opportunities. The climate-related disclosures for each company include reporting on Scope 1, 2 and 3 greenhouse gas emissions from normal business activities. For most companies who are not in the industrial or resource sectors, the major source of emissions will be the buildings that they own or control. These are Scope 1 or 2 emissions. So understanding the location of these buildings and their emissions is important as there are location-specific variables that may affect the building emissions. For example, variation in building energy sources. So the availability of renewable energy sources as compared to fossil fuel electricity sources. So therefore, if you're in a building in Tasmania versus a building in Sydney, there may be availability of hydroelectric sources as compared to mainly fossil fuel energy sources. The climate and environmental conditions, passive versus active heating and cooling measures from building constructions. So building in cool climates may require more heating, and conversely, buildings in hotter climates may require more cooling. If you can build your building from materials that allow a more passive approach to heating and cooling, then you can save energy and use less power, and therefore produce less emissions. Transport and infrastructure. The location of the building affects how people access it, your workers or your residents. The availability of public transportation versus private vehicle usage in a particular location. So if your building's in the middle of a CBD with good public transport versus a building on, say, a city fringe where more private vehicle use is required, then that's going to affect the emissions associated with that building. Local climate policies. For example, accelerating net zero buildings. That's a New South Wales government-funded initiative to boost the transition of non-residential buildings towards net zero emissions. And other similar policies exist in other states and territories, for example. Geoscape is developing an emissions attribute for our comprehensive buildings data set. And you can see in the background, there's a little GIF playing with an illustration of this prototype data set. Just to give you an overview. The aim is to provide a baseline emissions value for our buildings in Australia. I just said a prototype of this emissions attribute is available as a demo on the Geoscape hub. I'll display a link to where this is located at the end of this presentation. So if you'd like to have a look at the Geoscape hub, access this prototype building emissions data set and provide some feedback, that would be fantastic to us. And you can see, if you have a chance to have a look at this little movie in the background, we have a net lettable area attribute, whether or not the building has solar panels, the number of floors, and total CO2 emitted by that building attribute, and that's total CO2 per meter squared net lettable area. And there are also other building attributes as well from our standard buildings data set as well. Again, I'll provide the link to that prototype at the end of the presentation. Agriculture. So agriculture in Australia, it's a very diverse industry, both in terms of the commodities produced and the geographic distribution across Australia. As an industry, agriculture is very sensitive to changes in climate and the resulting variations in weather. And farmers are typically very good at applying past weather experiences to adapt farming practices to maximize productivity and profitability. However, when climate and therefore weather begins to vary unpredictably or outside accepted norms for a particular region, these past experiences become of less value and the farmer is unable to adapt and productivity declines. So to maintain profitability in a changing climate, new farming methods, practices, crops, or stock may need to be utilised. So access to accurate and reliable location data provides agribusinesses and farms with a strategic advantage in this situation. In some situations, there may be a valid choice to move away from traditional agriculture and embrace new technologies such as renewable energy generation or solar farming. Here, location data is critical for the placement of, say, solar panels for optimized energy generation. Location data is also instrumental for meeting new regulations such as the European Union Deforestation Regulation, the EUDR, by offering traceability and proof of sustainable practices. As stated earlier, from the beginning of 2025, companies in Australia are required to disclose their climate-related risks and opportunities. Companies with a financial interest in agriculture, such as banks and other lending institutions, are required to determine the greenhouse gas emissions of their portfolio of agricultural properties. This can only be achieved by relating a property land title to a location. Then the property is spatially enabled. Once a property is spatially enabled, it can be mapped and given a whole series of additional attributes. For emissions reporting, these attributes could include CO2 emissions per hectare, land use and land cover. Companies that insure agribusinesses may require a different set of attributes such as natural peril risk, for example, drought, for a farm in a particular location. Data shows that in 2023, approximately 87% of the Australian population lived in an urban environment, and this figure is projected to increase. Understanding how climate change affects urban environments is therefore of paramount importance. We've already mentioned how recent climate change over the past 20 years has increased the occurrence of extreme heat events, such as days over 35 degrees C and heat waves. Urban environments also exacerbate heat stress because of man-made materials and increased population density. This is detectable through such phenomena as urban heat islands. These are areas of higher air temperature. When we consider natural perils in terms of their total mortality, extreme heat events are the leading cause of death and injury-related hospitalisation in Australia, and that's data from the Australian Institute of Health and Welfare. Urban areas are particularly at risk of increasing heat-related morbidity and mortality because of climate change. Using location data, we can identify those areas particularly at risk and mandate solutions to reduce urban temperatures, such as light-coloured building roofs, high emissivity, I always trip over this word, sorry, high emissivity, I'll just skip over it, building materials, urban green spaces and trees. In Australia's major cities, there's a continuing pressure to build new housing for an increasing population. Typically, these housing developments are taking place on the fringe of most cities in previously undeveloped greenfield areas. In the rush to develop, housing is being constructed in locations that are subject to various natural peril hazards, such as flooding and bushfire. In the example shown on the slide, new housing is being developed and is under construction in the Hawkesbury and Nepean floodplain. This area flooded during the 2021-2022 floods. As climate change increases the frequency of extreme rainfall events, the probability of flooding will only increase in new development areas such as these. Building attributes such as first floor elevation, when coupled with flood models, can demonstrate the likelihood of building inundation occurring during these flood events. Geoscape provides detailed characteristics for every building in Australia. These spatially linked data can be used for a variety of purposes. Risk analytics for insurability, the impact of natural perils on these buildings, and urban planning. For example, as climate changes, understanding the impact of increased rainfall on flood levels and the subsequent effect on buildings with first floor elevation below a certain height to determine whether or not buildings or a whole series of buildings are going to be affected in a particular rainfall event. So that concludes the presentation section of this webinar. would anybody like to submit any questions through the Q&A function of the webinar for any of the presenters that have presented?
Thanks, Stu. Look, maybe I'll just try and sum up from a Geoscape lens. There's a lot of very valuable information that's available, but tailoring it to your business and your business objectives requires additional effort, support. If not Geoscape, if not the Resilient Buildings Council, if not some of the partners in part of the network, you need to start to, my recommendation is to start to try and think spatially, think about where problems, and you can unlock a whole bunch of capability to help drive decision making. So we're really excited to participate in an event like this. We thank Kate and Jeff for their work and being part of the conversation today. Throwing back now to Stu to see if there are any questions.
How much of this data is open for public use from Supriya Pera? Sorry if I pronounced your name wrong there. The Geoscape data presented, the GNAF core data set is freely available. The other Geoscape data sets are, well, talk to us and we can sell you some data by all means. As for other data sets, it depends which data you'd like. I mean, we talk to us and we can guide you in what data is available out there and how we can work with you on your particular application. And we can contact you after the webinar.
And I do see a question there from Michael now. Are we considering surrounding factors like the situation surrounding the building itself? So the answer to that is we've started with the object and that reflects the building. The industry is now sophisticated enough to start to pull insights at scale now around the surrounding elements of the building, and we are starting to consider the idea of condition of a property as one of the ingredients that you might be able to derive from image sources. The skill is being able to repeat and being able to deliver at scale. And so we're in the early days of seeking to move into that space, but the intent is for us to be able to bring more enriched information for the context of the decision that you're looking to make.
Another question, Michael, from Francesca. Can the data on buildings/housing be accessed for research purposes?
Yes, and there are different vehicles in ways that you can do that. Auran in the tertiary sector is a key partner that the organisation works with for access into lots of different, I guess, applications. So I would start with Auran if you're in the tertiary sector. If not, then I'd urge you to reach out to Geoscape directly.
Another one here. I'm not sure who this is aimed at, but does your data consider various climate scenarios and timeframes? Intergovernmental Panel on Climate Change, Marnie Punt.
So I think we're projecting further into the future there, and I'm reflecting that we're talking to different climate scenarios and how they will impact the different ratings and, I guess, scenarios that are applicable. For our base products itself, I think the focus is on the asset or the building or the land parcel. When you start to layer in the climate vulnerabilities, then yes, we would be seeking to, I guess, integrate those different climate futures into forecasts, etc. We would expect to be guided a little bit by industry and specialists to be able to help with that. There's also...
Sorry, Michael.
Just jumping in, if you're a not-for-profit or a government, often the accessibility of data, so in a commercial world, we're often talking about commercially available data supplies. the capability that we're talking to can even get more sophisticated under governance arrangements that enable and unlock access to more data. So from a government not-for-profit standpoint, where there is, I guess, additional data holdings, we believe that the intelligence and the insights that you can glean from the utilisation of location intelligence can only grow. So whilst we probably speak more so to the commercial world and the commercial sector, which is a lot of the intent today, the governments and not-for-profits are certainly not excluded from the capabilities that we've spoken to.
Michael, there's a question from Damien Simmons regarding the hazard information. I suspect that's aimed at where we're getting our hazard information from, so I can answer that, and it's a combination.
Answer in there, Jeff, for Damien. Sorry, I was just writing a response while you guys were talking.
Okay. Just quickly, yes, we ask questions which have effectively established what we call the allotment factors. So obviously the building is very important, but objects close to the house that might also initiate or contribute to the loss of the house. You know, parking your fiberglass boat full of life jackets and tree litter within a metre of the house is a very bad idea. So some of the hazards and risk information comes as part of the questions we ask in the app. The rest of it comes from various external sources. So we have a couple of partners who provide professional assessment of environmental risk, and we're also obviously relying when it's feasible on council reports. Obviously, a local government area usually controls both the bushfire prone mapping as well as flood levels and flood mapping. So yeah, it's a little bit multifaceted. We would love to have everything in just one location. PSMA could pick it all up and just combine it for us. Thank you very much. That'd be great. But yes, at the moment we're sort of picking up things from various sources, ranging from national mapping sets that CSIRO might be driving right down to individual councils driving out their flood models. Thanks.
We've got a specific question for Kate here as well. Would you know if AIA will be one of the new participating insurers at Renew Incentives February 25?
I think they are on the list. I think there's about 12 insurers at the moment going through the underwriting process. I'll check on AIA. I can't quite remember, sorry. I'll have to follow up on that one.
Yeah. And we have another one here, a Geoscape question. Do you have plans to update your GNAF address data more frequently than quarterly? With more and more new housing developments hitting the market, currency of this data needs to keep up.
So that's an excellent question. GNAF itself is a quarterly data set. It's a pretty sophisticated and heavy data set. And so the notion of updating that data set more frequently is a challenge. But that said, and when Jeff spoke to some of the capabilities that are being accessed around the predictive address verification engine and being able to use addresses more frequently, we are updating address holdings every day. That I guess information, or as frequently as daily, where addresses are supplied from the address custodians at state and territory levels. That frequently. So there is a daily updated data set that feeds ultimately a GNAF quarterly publication. But in terms of the real time and being able more near real time information sources, they are, I guess, part of the API framework and the verification engine. GNAF is a very sophisticated and complex data set, so the ability to be able to utilise it in the same way more frequently is are challenges. They're challenges that we're leaning into. We'd like to be able to produce data more frequently and made available, but at the moment it is through address verification engines where you'll see more frequently updated data sets.
We've got a question from Wesley Koros. Have you considered looking into supporting indoor maps? Is that aimed at us or Resilient Building Council? I'm not sure.
It's an excellent question, and I'll have a stab at going. So the amount of indoor is really based on the availability of information and how it'll integrate to the systems that we have, I guess, in the data sets that we already have in place. It's a very logical extension. However, the demand for indoor location-related services in the same way that we cover the scale of Australia hasn't been apparent yet, but logically, I would imagine for the right use case and the right, opportunity, then, this capability certainly leverages itself to be able to support indoor navigation and indoor analysis.
And just to add on there, we collect some indoor information for flood, energy and heat wave that's relevant to the models.
I put up the slide which has the links to the Resilient Building Council Building Resilience Rating app as well, and also the Geoscape Hub and the buildings emissions prototype on the Geoscape Hub as well. Please go and have a look at all three links. Please feel free to take a screenshot if you haven't already and explore all three. Oh, Sean Bennett, hand up there.
Yeah. And our intent is, per one of the questions, to make the recording available such that you might be able to share and speak to your colleagues, and we will put a summary pack of information together to be sent out also after the fact.
Well, if there are no more questions or comments, I'll end the webinar there, and I'd like to thank everybody for their attendance and some really valuable questions. And thank the Resilient Building Council participants, Kate Cotter and Jeff Emmerton, for coming along and presenting a really valuable overview of the app. And thank you very much, both. And Michael, thank you.
And thanks to you, Stu. Thanks, everyone. Have a great day.